All right, so by the end of the hour, you'll be good at graphing logs, and without a calculator, because if you had a calculator, it's super easy. And we're going to just do a little bit of review of applications. In fact, we're going to start with that. By the way, for those listening at home, this video is going to actually cover both today's and tomorrow's lesson. Logs day 8 is the one we would normally be doing today, and tomorrow's is log day 9. All right, so for today, we're basically just graphing. This is just reminding me to tell you that there's a test on Friday. This coming Friday is the official test. You got the quiz back the other day. You didn't look at it very long, so if you want to look at it again today, I'd be happy to let you do that. The test is Friday, and it's basically got some of the same stuff that the quiz had on it, plus some more. All right, let's move on to actually number 1 on this little blue sheet. It says warm up. Solve that. Well, basically, you stick the S in the right spot and you solve it. You'll need a calculator, though. So everybody take a second, grab your calculator. Let me just a second. 45 plus should be a log base 10 of 95. That's with a calculator. Use the calculator. I'm going to pause for a second while you do that. Okay, here's where I would have thought you would have done it. I would have thought you would have put the S in, the 45, in over here. And then you can add 176 to both sides, and that's going to make 221, thank you. And then you divide by 116 on both sides, and you'd have log base 10 of A plus 40. All right, if this number had worked out nice, it wouldn't have been that bad, but I think, doesn't it come out to like 1.9? Okay, so when it says no calculator next to it, there's just no way. If this had come out to like a 2, then you could have done it without the calculator probably, because you're just going to go 10 to the power of that. If it had been 10 to the second, that would have been easy, right? So I think what the teacher meant when they set this up and said no calculator is they meant to put in a number that would make this turn out to 2. And then you could have taken 10 squared is 100 equals A plus 40, and that would have been easy to solve in your head. Anyway, as it is though, 10 to the 9.1 is going to be like not 100. It's going to be like 90 or 80 or something. What is it? 80.3? And then that's equal to A plus 40. And then you just subtract 40 from both sides. You get about 40.3. That is rounded, but that is about right. Raise your hand if you had about 40.3 for that. Okay, good. So that's applications. They're going to give you an equation. You're going to stick the number in the right spot and solve it. They're really not that hard. As long as you can plug and chug, we call that. Plug it into the equation and chug through it. That's the easy kind. All right, this one's graphing, though, and that one's more important. That's the stuff we're mostly talking about today. Log base 4. A few thoughts. I hope you know that logs are like a tree, you know, like this is the tree, except it's been blown over in the wind. And it always goes through this spot right there. Why? Because that's the whole, if you make the argument 1, if this is 1, if you won the argument, you get nothing. Remember how it's 0? 1 comma 0 is always going to be on your starting graphs, your parent graphs for these. All right, so there's the base graph, and then would I have gotten credit on a graphing question on the test if I had my asymptote here and I had my red line there? Well, I'm close, but I only have 1 accurate point. I would expect you to have at least 2 accurate points. It'd be better if you had 3, but 2 accurate points. So I need to find 1 more point. So you go like this, you make an XY chart, and you find a number that would work nicely. You don't want to just pick random numbers. Like, let's say I pick X to be 3. Do you get how log base 4 of 3 is not easy to do in your head? So you don't want to pick 3. Don't pick 3. Bad idea. Pick 1, because if you won the argument, you put a 1 right here, you get nothing. You get 0. 1, 0 is a good point. What else is smart to put right there? 4, because log base 4 of 4 works out nice. What is it, by the way? That should be an automatic answer. What? 1. Because it's the exponent on this. If these two are the same, the bases are the same, the answer is the exponent. Okay, and then there's one other number. If you wanted to get a 3rd point, this is a pretty slick way to do it. You take 1 over the base. If the base is 4, you take 1 over the base, which would be 1/4. And if I put in 1/4 for my x, then you got to be smart about how you write that. Do you get that 1/4 can be written as 4 to the negative 1? and I now made my bases the same, and so my answer is -1. It just happened there. I took 1 over the base as my number to put in. I rewrote it like this because 4 to the -1 means 1/4. And then once this number and this number were the same, the answer was the exponent. So that is definitely a tricky one. 1/4 comma -1 goes like right about there. But the other one that was way easier was 4 comma 1 over 4 up 1. Can you see I was actually off a fair amount in my estimate graph, my kind of quick graph? Should be really going here. I'll make it in black. It should be going like that. Okay, so it makes a much tighter turn than I made it have. That log is way blown over onto the ground. Okay, that is the basics of a graph that has at least 2, I'm going to use these 2 accurate points. This one's a little less accurate, but it's okay if you need a third one. All right, move on to this one. This is just a reminder that when you have, I know you know what the graph looks like. We just did it. But if I do a red one, a green one, and a blue one, which one, if I call these A, B, and C, which one's A, B, and C? Is the red one, the red picture I drew, is that more like A, B, or C? This is like A. This is like B, and this is like C. How can I tell? Because the one with the biggest base has the tightest turn. Turns really sharply compared to the others. So the bigger the base is, the tighter the turn is that it makes. All right, let's move on. Name the transformation. There's official names for these, and then there's the like folksy way to say it. That one moves left or right. Come on, what is it? That's left 3, okay? How about this one? Up 3, and we don't need any complicated names for those. These are the kind you have to get more complicated with. If you just say stretch, you will get it marked wrong. Which kind of stretch? Vertical stretch, and why would you still get it marked wrong? Because you didn't say what the factor was. Vertical stretch factor what? 2. Good. This one. Got to be careful. Write it out, everybody. Write out what you think it is. I'll tell you if you're right or wrong. Turn it my way. What's that fourth one called? A what? Needs at least 2 words. Could be as many as 4. Flip is too folksy. It's not the official word. Is not flip. What's the official name for flip? Just say it if you know it. Reflection. Good. So, make sure it's, yeah, that is what I was looking for. One of the right ways to say it. Okay, yes, that's an okay way to say it. Yup. That's a good way to say it. Zoom in on it a little bit more. Can't read it. The wrong axis. It goes this way. It's reflecting this way. Other axis. Yup. Okay, good. 2 in the back corner I did not see. I'll get you later. Okay, the last one. This one I just want you to kind of like think through the 5 things. And I'm going to see, last hour nobody could do it. I'm going to see if any of you know of the 5 things that you'd need to do on this problem. What order should you do them in? What should be first? What should be second? What should be third? That's a pre-calc question that nobody could get right last hour. We'll see if you can do it. I'll give you a hint. You have to start on the inside. Technically, there is another way to do it, but I really don't think you'd get it right if you didn't start on the inside. I'll pause for a second while you work that through. Go. Okay, so in order, you should start on the inside. And of these 2 things, you got to think in terms of what's the normal order. Please excuse my dear Aunt Sally. The parentheses are first, blah, blah, blah. So which way am I doing it? Backwards. That's first. Add and subtract are first because we're doing it backwards because we're on the inside. It's counterintuitive. So that should be first. Right 6. How many of you had that right? All right. We started with a lot more than last hour. Maybe there's a chance. Now, of course, the other inside one needs to be next. And that is not a stretch. That's a shrink. That is a inside. You know, remember high-vo? Horizontal on the inside, vertical on the outside. Do you remember me saying that? It's important. It's good to memorize. So that is on the inside, so it's horizontal. So that is a horizontal shrink factor 1/3. Very good. How many of you remembered all of that? Only one person. Okay. Then, factor 3 would be wrong. Has to be factor 1/3. I know it's harsh, but I'm trying to teach you for pre-calc when it really matters. Okay? Here the order doesn't matter. Although if you had this written and you said factor 3 on a shrink, a factor 3 doesn't make sense. Factor 3 makes you get bigger when you times by 3. So it should be factor 1/3. Okay, back to this. We have to go to the outside now. We've done these two things. So the outside stuff, those two are first, because they're multiplies. And on the outside, you do it in normal order, and multiply comes before add and subtract. So then of these two, you can do either order, does not matter. So these next two does not matter. I recommend you stretch before you flip, because it works well to prevent muscle injuries. Stretch before you flip. So I'm going to recommend, but it doesn't really matter, that we do the stretch. Is that a stretch? No, it's actually a shrink. It's a vertical shrink factor 1/2. Why is it okay to have a half this time? Because the shrink should be a fraction, and that is a fraction, so we're good. And then the next one is a reflection, and you could call it a reflection over the seed. It's on the outside, so it's high-vo, vertical on the outside. Okay, so that is a vertical reflect. Or you could say a reflect over the x, either way. And the last thing is this, which is down 1. Did anybody have it in the right order? Really did? All of them? Sweet. Nice job. I have one person out of 60 so far who's pulled that off. Okay, that's a pre-calc question. Just like that, seriously, next year if you're in my regular pre-calc class, you'll be doing the same exact thing. All right, moving on. If you are graphing, it is not a bad idea to make a list of the parent points and then move them or reflect them and stuff. Let's do one. If we had this, XY chart is a good thing to use, but I would first generally picture where it is. Logs look like a tree that's blown over. Looks kind of like that. I need a couple important points. Well, that's one of them. It only goes through that for sure. Then I have to think. And I have to think, if I am doing log base 2 as my parent graph, I could go and make a list of the parent points of that, but I personally like it better to just get a quick sketch of it. Here's the asymptote line, and move that whole sketch of it. Actually, I'll take this and move it this way. It's +3, that means left 3. So I'm going to actually move the graph over this way. There. Now, I've moved it over 3 spots to the left, but why would I not get credit? I only have 1 accurate point. I need to have 2 accurate points. So I need to make a list. Well, if I put in, what would be nice to have right there? 2. Right. Because if I had log base 2 of 2, that works out perfect. So a 2 is a great idea. If I put in a 2, what will the answer be? 1. 2 comma 1 should be on my graph. If I go over 2 and up 1, do you see that there is not a point right there? So I was doing this a little too rough, sketchy. That wasn't accurate. How about if I check at -2? See how if I put a -2 in, that seems kind of important? What if I put a -2 in right here? What did I just do? I made the argument equal what? 1. And if you won the argument, you get 0. You get nothing. So I put in -2, I get 0. So -2 comma 0 is that spot right there. Yay. So I was pretty close, but now that would get full credit on the test because it's got 2 accurate points. Now, could you have a 3rd accurate point? Yes, but it would be a tricky one. You'd have to make this thing right here. Maybe make it equal 4, because then log base 2 of 4, if that was a 4 right there, then it would really be 2 squared, wouldn't it? So then the answer would be 2. So if I put in how do I get a 4 to be in there? If x was 1. So those get harder to do, but you could handle it. And then 3 plus 1 is 4, and that really is 2 squared. And then log base 2 of 2 squared is 2. 1 comma 2. Uh-oh, what happened? Thank you, you're right. That should have been -1 right there. Dang. Because -1 plus 3 will make 2, and then log base 2 of 2 can actually work. So you're right, the x was -1, and what I get out of that is a 1. You're right. -1, 1. Okay, I need to change all kinds of things here. Oops. -1, 1. Well, that actually is on my graph. There. So my black one wasn't as bad as I thought. Okay, now I'm going to, sorry about that, I screwed that point up. I'm going to double check this next one. When I put in -2 right here, that makes a 1 in the argument. When you win the argument, you get nothing. That one's correct. -2, 0, and that is in the right spot also. And then this last one, if I put in a 1, 3 plus 1 makes 4. Log base 2 of 4 comes out to 2, so that one's also correct. 1 comma 2. Hey, my black sketch ended up being pretty accurate. I had 3 good points on it. Thank you for catching that. I should have double checked it, but I wasn't being careful. Okay, that is a typical graphing question. I want you to do not this one. Yeah, do that one. Do the yellow one. It's not moved to the left. It seems like it's moved to the left just like the last one, but this one's actually moved up. Remember, if all you have is an asymptote and 1 accurate point, you would not get credit on the test. You'd want 2 accurate points. At least 2 is my official line, just because sometimes the 3rd point really isn't hard to find, and it's a good idea. 3 points usually determine a curve. Usually 2 points determine a straight line, and 3 determine a curve. It's just really hard to find that 3rd point sometimes. I'm going to pause for a second while you try making a nice accurate graph here. All right, so I'm back, and here's the first thought. Generally, they look like this, and generally the asymptote, I can use a nice little feature of the smartboard here, looks like that. Now, where should I move it? Up, down, left, right? Up. How far? 3. So I'm going to take this, and I'm going to move it up. 1, 2, 3. Now, is it likely I'd get full credit for that graph? Nope, because it doesn't have 2 accurate points dotted on it. Okay, so I need to make a little XY chart. And then from here, you want to be smart about it. Don't just grab a random number like, I want to put in 3, because then log base 2 of 3 doesn't work out nice. Pick numbers that do work out nice. So, give me one that would work out nice. If x was what? 1. If you won the argument, you know nothing. Now, here's a common screw up. People put a 1 and go, oh, so the answer is 0, because if you won the argument, you get nothing. This is 0, but then you got to add 3. So 1 goes with 3. Raise your hand if you had that one right. Okay, good. And then another option is to put in 2. That's the same as the base. If I put a 2 right here, then I'd get 1 for this, plus the 3 makes 4. 2 comma 4, and that's 2 accurate points, and I'll have enough. So 1 comma 3, over 1 up 3. Ooh, I was definitely off. And then over 2 up 4. See, I was definitely a little low on that one. So my final answer should be this red one, which would get more credit because I got 2 accurate points, and I've got the asymptote in the right spot. Get the black one out of there. All right, any questions? All right. I think that's enough for today. There's a few more practice we could do, and this one's just brutal if you want like a super insane hard challenge problem. That is about as, we would never give you one that tough on the test, don't worry. But, and pre-calc maybe, but not in this class. All right, so today's first part of the assignment is worksheet day 8. Now, unfortunately, this is the part where we got to go in and learn the second part. It's not that hard, though. It's a pretty easy day. So I'm going to pause for a second while I pull up the second smartboard. Here I go. This is now for logs day 9. It's about natural log. And I'm going to go kind of quick because I'm already halfway through the lesson time here, so I have to go fast because we're munching 2 days down into 1. Basically, what you really need to know is that base E is a new way to have a log. It's a log that doesn't have a normal base. You know how the log, here's a normal one, y equals log base 2 of x. But what if this 2, this base number, wasn't a 2? What if it was a letter? Well, there's only one. How about if it was pi? What if I put pi in there? Would you know what to do? Isn't pi pretty much 3.14? Okay, well, there's one more letter you need to learn that's kind of like that. E is pretty much, did I mention it to you before? Do you remember what it is about? 2.718, very good. So really, it's not that complicated. E is about 2.718. Well, E is kind of cool because it was formed this way. It was formed by taking 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, and it goes on forever. That also implies that E is kind of like pi. You know how pi goes on forever and never repeats? This one, you could keep doing it for the rest of your life and finding the next digit of E, just like some people get obsessed with pi that way. All right? You'll understand this a lot better when you're in pre-calc to be able to understand what the limits are. But don't worry about that for right now. Keep it simple for now. E is 2.718 about. So if you see log base E, then that means log base 2.718. That's all. So you could do the same kind of stuff with it that you could if it says log 2. What is it the closest to? That's a nice simple number. Come on, 2.718 is about close to what? 3. So it's pretty much like log base 3. It's going to be just like log base 3, except it doesn't take quite as sharp a turn, that's all. Because, you know, the bigger the number is on the base, the sharper the turn they are. All right, so whenever you see log base E, you usually don't write it like that. You usually say ln. You ever wondered what that button on your calculator was? It said ln. What it means is log base E. There's a button on your calculator that says ln. And it's not even one of those like raised up functions. It's actually got its own button. So that must mean that you use it a fair amount. Well, we don't use it too much this year. Again, you can use a lot more next year. All right. So the best tip of the day is whenever you see an ln in a problem, is replace it with log base E. So this is the exact same problem as this, except I rewrote it with a log base E. And now can you see that there's 2 E's in it and that the bases are the same? And therefore, what's the answer to that question? 3. Done. That's the answer is 3. They can be very simple like that. All right? Now I want to make a quick sketch. Log base 2, remember that's got a small base, so it isn't making a very sharp turn, so it's something like that. Log base 3, it's making a little sharper turn. Log x, what? It doesn't have a base. What base is it then? Base 10, so that's a really sharp turn. Okay. Log base 25, insanely sharp turn. Okay. Log base E. What is E pretty much? 3. So therefore, it should be pretty much identical to this one. So I'm going to use my cloning feature so that I know it'll be identical. I just got to make sure it goes through the right spots. There. See? Get my point? It's not exactly. Okay, so it's not exactly 3, but it's really close to that. All right. And what is lnx? Is that the same exact thing as log base E? So I can clone it again. And bring it over here, and there we go. Pretty much, well, these two are exactly the same. This one is pretty much the same because it's 2.718 versus 3. Getting my point? Pretty much like the log base 3. Okay, now if you had this problem, for instance, evaluate ln e to the 15th. My tip of the day was replace ln with what? Log base e. And then you put the e to the 15. You see how the answer just jumps right out at you then? Okay, and if you're looking at this, the answer is not going to just jump out at you. You've got to do what I said. Replace the ln with a log base e, and then the answer jumps out at you. All right, remember what I said. What do you replace the log ln with? So this is e to the power of log base e of 2. Do you remember that pattern? If these two are the same, that's the answer. So the answer's 2. Okay. Some of you aren't with me, and I know that. I want you back with me. Okay, I'm almost done here. So if you had to do this on your calculator, ln of e to the 15, just in case you didn't know, the e is above the divide key. Grab your calculator, type in ln button first, and then the e, which is again above the divide key. Power of means like caret 15. ln e. So these are the keys you push. ln button, e, which is above the divide key. Power of 15. Enter. What'd you get? 15? Why on earth would that be? Because this is really log base e, right? And if e answers 15, see? All right, good enough. Application, basically, they give you a formula. What are you going to do? Plug and chug. You're going to stick in numbers. But e is not a variable. A lot of people get confused on that. They're like, never told me e. E is 2.718. You want to use 2.718, you're always going to be off a little bit. Because why? Because you rounded it. What if you use the calculator's version of e? It'll be a lot more accurate. But do you think the calculator actually puts in real e? No, it also rounds it. Because calculators can't give you infinite numbers, infinite decimals. So just remember as you're putting it in, you already know e. It's in the calculator. It's 2.718, blah, blah, blah. And the r in this problem is the rate. That's right here. Don't forget that's 0.09. And the t is, it says, how long will it take? It means we don't know t. So we'd have to solve for t. All right, so 5,000 is the principal, so that's going to go in here. So we'd say amount would be 5,000 e to the rt. I know e. It's approximately 2.718. I'm going to say that it's okay on this practice problem. Just use 3 if you want to. And now, no, sorry, 2.718. Use 2.718. Don't use the E button if you don't want to, but R8 is 0.09. T. Wait a minute, how am I supposed to solve for T? You have to know how to do logs. Do you get how this is a base? And this is the exponent? We haven't done this in so long, you may have forgotten how to rewrite this. Log, what's the base? 2.718, which is also known as E, log base E, of some amount. Wait a minute, they never told me the amount here. It says double your money. What's that amount then if you're supposed to double your money? No. You had 5,000, you're going to double it. 10,000. There we go. Now, I have to rewrite this thing. I better start by dividing by 5,000 on both sides. Cancels. What's 10,000 over 5,000? 2. So, the new problem says 2 equals E, 2.718, to the 0.09t. Can you rewrite that as a log? Yes, you can. Log base E, also known as ln, of 2, and you always have to jump back and forth, equals that, 0.09t. T's almost alone. That a calculator could get for you. And then you divide by 0.09 on both sides. So from there, it's easy. Calculator does this, divide by 0.09. So what really happened was I stuck my numbers in my formula here, here, and there. And then I stuck E in there too. And then I solving it by rewriting it as a log problem like this. And once it's a log problem, it's not that hard. Your calculator can solve it once it's a log problem. If it's like this, you can't solve it with your calculator. You can't, unless you know how to do logs. The only exception is you could graph both sides and see where they cross, because that works all the time, every time. That's why it's such a powerful ACT strategy. It's because you won't even have to know logs. You could just graph both sides. Yes? So if you were going to graph this, you would use log base e of 2, ln, it means the same as log base e, so yes, ln 2 equals 0.09 t. So you'd graph this side, ln 2, and then you graph this other one as a separate line, and then you see where they cross. But we're so far into it that I wouldn't even I wouldn't use the graphing calculator now. I mean, I'd use it, but I'd use it to go get a number for this. The calculator tells you some decimal. You divide that by 0.09, and you'll have some decimal divided by 0.09. All right, so these are not super easy application problems because instead of just plugging it in and solving it, you end up having to take something like this and rewrite it as a log. So my last thing I want to make sure you know how to do is, let's say I had this. Let's say that was your problem. Tell me how to rewrite that as a log, because once it's a log, it'll be easy. Okay, the first key is you cannot do it the way I have written it. How do you have to start? Do you get how there's two things here and there shouldn't be if I'm going to rewrite it as a log? So how do I start? Divide by 9. Good. That's gone. Now I can rewrite it as a log because I have a base, I have an exponent, and I got something on the other side. Try writing this as a log now. It's log base something of something equals something. Try it. Turn it towards me when you think you have it. I know it's been a long day of learning, but the cool part is you have all day tomorrow then. Okay, log base e of, yep, you did it right. Good job. You did it right. You did it missing a 9, 7/9. Nope. Yup. 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 Interesting that everybody wrote log base e. That was right. And then you jump to the other side of 7/9. A lot of people goofed that part up. This is the whole thing. It's not just the top. Equals, and then you got to jump back over here. 0.5r. But nobody wrote ln. Isn't log base e the same thing as ln? It would have worked either way. All right. Listen closely. On the first assignment, you can skip problems A and C wherever you see them. Okay, so there's one in like the beginning of the assignment, there's one at the end of the assignment, I think there might be one in the middle. You may skip parts A and C on the first assignment. On the second assignment, do all of them. And that's your assignment for the next 2 days. All right, have a great day.